Hi students, welcome to my channel. In today's session, I am going to explain what is valence bond theory. It's the most important topic from coordination compounds. So let's discuss one by one. First, what is valence? Valence means it is the outer shell, right? So valence orbital means orbitals present in valence shell. Here metal and ligand going to form a bond. Here ligand has pair of electrons. It donates its electrons to vacant metal orbital and forms a bond. So it is a type of coordinate covalent bond. Like this complexes are formed. So this is explained by valence bond theory. So here application of valence bond theory is using this theory we can determine magnetic behavior, magnetic moment value, and hybridization and geometry of the metal complexes. So first two types of complexes we can find. One is tetrahedral complexes, another is octahedral. Tetrahedral means tetra means 4. So its coordination number is 4. For tetrahedral complexes, coordination number is 4. Octa means 6. In organic chemistry, octa represents 6. So coordination compound for these complexes is 6. So see here, today I am going to discuss 4 complexes. Here I am giving 8 points to complete the valence bond theory, students. If you are thorough in these 8 points, you can easily find out the complex hybridization, magnetic moment and magnetic behavior, everything. So first I am taking nickel complex, nickel tetrachloro complex. See here, oxidation state of central metal ion, first point. So first you have to write the atom, nickel atom. It is a atomic number is a 28. So the configuration is 3d8 4s2. But metal ion involved in the complex formation, not metal atoms. So here metal ion is a nickel plus 2. So nickel plus 2 is 3d8. Okay students, next d orbital splitting. So here what are the orbitals involved in the complex formation? 3d orbital, 4s orbital, 4p, 4d. So these 4 orbitals usually involved in bond formation with ligands. So here 8 electrons in D, here everything is 0. Next ligand. What is the ligand here? It is a chlorine ligand. So it is named as a chloro. Negative ligand named as a chloro. It is what type of ligand means? Weak ligand. It's a weak field ligand. Weak field ligand means what happen means it does not pair the electrons. No pairing takes place. No pairing takes place. This is the important thing, students. You should know weak field ligand means no pairing takes place in vacant, or that is metal orbitals, vacant metal orbitals. Next complex. See here you have to fill the electrons in the orbitals. See first you have to fill this 8 electrons of metal ion. So 1, 2, 3, 4, 5, 6, 7, 8. Everything is 0. Now here weak field means no pairing. Here 2 unpaired electrons are there, but it is a weak ligand, that's why no pairing takes place. So here now ligand electrons involved in the vacant orbitals in metal. Now in this orbitals, now ligands approach. See here 4 chlorine ligands are there. Each chlorine donates a pair of electrons. So this is Cl minus, this is one pair, this is one pair, this is one pair. Everything is Cl minus. So now totally 4 Cl minus. Why it is 4? In this complex only 4 chlorine ligands are approached. Clear? Okay, next. It involves either inner d orbital or not. This does not involve inner d orbital. That means ligand does not approach inner 3d orbital. So it is outer orbital type. It is outer orbital. And the spin type is, the spin type depends upon the field of ligand. It is a weak field ligand means the spin type is high spin. Suppose the ligand is strong means it is low spin because pairing takes place. Next, magnetic behavior. Here it consists of two unpaired electrons. So the complex is paramagnetic in nature. Next, magnetic moment. Using root of n into n plus 2 formula, we can find out. Here the value is 2.87. In previous video, I explained how to find the magnetic moment values. If you have doubts, you can see that video. Next, hybridization. See students, hybridization. Hybridization means nothing but what type of orbitals involved in the bond formation. See here, chlorine approaches 1s and 3p orbitals. So the hybridization is sp3. Totally it depends upon the ligands. So sp3 hybridization. sp3 hybridization means the complex's geometry is tetrahedral. The complex geometry is tetrahedral. That's all students. Using these 8 points, you can easily find out the hybridization and magnetic moment of valence bond theory complexes. Next example. But one thing you should know students about ligands. Strong field ligand means pairing takes place. And mostly it forms low spin complexes. It forms low spin. Weak field ligand means no pairing. It forms high spin complexes. Okay students. Example for strong field means cyano we can say. And sometimes amine act as a strong field ligand. And with the cobalt, oxalator act as a strong field ligand. Only with cobalt it acts as a strong field, otherwise it is a weak field. Next example for weak field means water, chloro, fluoro, bromo, sulfato. These are weak field ligands, as well as with oxygen or with the carbonyl. So these are weak field ligand students. Here with the carbon means, so with the oxygen means it is a weak field, with the carbon means it is a strong field. So here carbonyl is a strong field ligand. So mostly water and halogens and sulfur, with the sulfur forming bond means it is a weak field ligand. So these are example for strong field and weak field ligands. So next example, hexacyanoferrate. First, what is the first point? Oxidation number. First, here Fe atom. Fe means 26, 3d6, 4s2. Here Fe3 plus involved. Fe3 plus means 3d, 5, 4s, 0. Next, d orbital splitting. How it splits? 3d, 4s, 4p, 4d. Here 3d orbital is known as inner orbital students. 3d orbital is inner orbital. 4d orbital is known as outer orbital. Okay. In 3d, now 5 electrons are there. Here everything 0. And ligand. It is a cyano ligand. Cyano ligand is a strong field ligand according to spectrochemical series. Strong field means what happens? Pairing takes place. That means it pairs electrons in 3d orbitals. Pairing takes place in 3d orbital. Okay, students, is a very, very important point. Next, complex formation. Here, what is the complex, students? FeCN6. That means 6 cyano ligands going to form a bond in metal orbitals. So first you have to fill the electrons. See now 3d 5. Fe3 plus means 3d 5. So 1, 2, 3, 4, 5. So now remaining orbitals, ligands can approach, but it is a strong ligand, right students? So here it pairs the electron. See here. Now this electron pairs here. So this electron paired with the first orbital and this electron paired with this orbital. Now what happens? See 1, 2, 3, 4. Here pairing takes place. So now because of the strong field ligand, now pairing takes place. Now two orbitals are vacant because strong field ligand requires two orbitals in 3D. That's why it pairs the electron. Now two d orbitals are vacant. In this space now ligand can approach. So here cyano is approaching two ligands. Here two ligands and here totally 6 ligands. See students, this is 1 orbital, 2 orbital, 3, 4, 5, 6. Totally 6 orbitals. So this is 3D, this is 4s, this is 4p, this is 4d. Okay. Now these are ligands. So now it used 3D orbital, that is inner orbital. So the orbital type is inner orbital. And what is a spin type student? It is a strong field. Strong field means it is a low spin complex. Next, magnetic behavior. It has 1 unpaired electron. After pairing only you have to check. Before that it has 5 unpaired electrons. You should not touch that. After pairing, is there any unpaired electrons or not? You have to check. Here 1 unpaired electrons. So it is a paramagnetic complex. 1 unpaired electron. Paramagnetic complex. Paramagnetic means it is attracted by magnetic field and magnetic moment value is 1.83 Bohr magneton. And what is the hybridization? So see students, it used 2 d orbital, inner d orbital. So first d2, next 1 s orbital and 3 p orbital. So d2 sp3 is the hybridization. Clear students? Whether it used inner 3 orbital or outer d orbital, you have to check. It depends. Hybridization fully depends upon the approach of ligands. So hybridization is d2sp3. So total power is 6. So it is octahedral complex. Clear students? Next, another here. Oxidation state. Here it is a cobalt complex, hexa aqua cobalt complex. Oxidation state. First cobalt, it is 27 atomic number. So 3d7, 4s2. This is for atom, but only metal ions involved in metal complexes. So cobalt, here oxidation state of cobalt is 3 plus. So 3 plus means it 3d6. 3d6 means orbital 3d6. 4s0, 4p0, 4d0. And ligand. Here it is a aqua. Water is named as aqua in coordination complexes. And aqua is a weak field ligand. Weak field means what students? No pairing. And complex. See here. Now total number of electrons 6. Now 6 electrons you have to fill in 3d orbital. This is 3d, 4s, 4p and 4d. This is outer orbital and this one is inner orbital. So now what happens? It is a weak field ligand. So no pairing takes place. So as it is, now ligand can approach. So first fill the electrons. 1, 2, 3, 4, 5 and 6. So total number of electrons 6. So 4 unpaired electrons here, weak field, no pairing takes place. As it is, this 4 electrons will be there. Now ligands are approaching. See here, here one ligand, here one ligand, here totally 6 ligands in the complex. So 4, 5, 6. So the hybridization is, now what is the hybridization students? Yes, P3, D2. Okay students, and it used outer orbital. It uses 4d orbital. So it's a outer orbital type. This complex is a outer orbital type. And weak field means it is a high spin complex. And magnetic behavior, it has 4 unpaired electrons. 4 unpaired electrons, hence it is paramagnetic. Clear students? And magnetic moment value is, it 4 unpaired electron means the value is 4.90 Bohr magneton. And hybridization is sp3d2. And geometry is octahedral. 6 means octahedral students, no other possibilities. Next complex. See, as it is. First, here see students, oxidation state. First point what? Oxidation state. So Mn, manganese is 25. So 3d5, 4s2. But here in this complex, oxidation state of manganese is plus 3. So it is 3d4. Next, orbital splitting. 3d, 4s, 4p, 4d. Here 4 electrons, here everything 0. Third one, ligand. Here ligand is a cyano ligand. So cyano is a strong field ligand. So pairing takes place. Okay students, next complex. See here, first you have to fill the electrons. 1, 2, 3, 4. It is 3d orbital. This is 4s, this is 4p, 4d. 4 electrons. But see here students, cyano ligand is a strong ligand, pairing takes place. So it pairs the electron. Okay students, usually it pairs the electrons. It pairs only one electron. This 4th electron is going to pair here. Yes students, because cyano, when strong ligand is there means pairing takes place. It requires only 2 d orbitals, not other. Students, only one pairing takes place. Now this is paired, remaining electrons as it is. Now see, 2 unpaired electrons are there. Cyano compounds requires 2 d orbitals, that's all. There is no another pairing takes place. It is very important point students. In 3d orbitals, whatever may be the ligands, it requires only 2 orbitals. That is enough for the ligand. Any other extra electrons are there, there is no pairing takes place. So only one pairing takes place. Only now 2 orbitals are vacant. Clear students? This one only we need. We need these 2 orbitals only, not other orbitals. So now ligands can approach here. So here ligand, here ligand. Now ligand. Totally 6 ligands are there. 1, 2, 3, 4, 5, 6. Okay students. Now what is the hybridization students? First D comes. So D2sp3. Clear students. Next orbital type. It uses 3d orbital. So it is inner orbital type. And what is the spin type students? It is strong field ligand, pairing takes place, so it is a low spin complex. Next, magnetic behavior. It has 2 unpaired electrons. It is paramagnetic. Clear students? And 2 unpaired electron means the value is 2.87 Bohr magneton. And hybridization is D2sp3 and octahedral. That's all students. Using these 8 points, you can easily solve the valence bond theory complexes. Easily you can write. And with like this point, you can write students. No need to explain in a verse. So like point by point means it will be easy for you to remember the complexes and steps, everything. So I hope you can understand the complex valence bond theory, how to complete that. Using this valence bond theory, you can find out orbital type, magnetic behavior, moment, everything students. If you like this video, please click on like button, share and subscribe to my channel. Please give your suggestions in comment box. Thank you for watching.